Hello, good morning everyone. Welcome to RP Educational, and this is the second lecture on the first topic. In this topic, in this lecture, we will discuss about the Newton's law of gravitations. Here, in 1687, Newton found this universal law of gravitation. According to him, suppose if you tie a ball with a rope and spin it about your about the one free end of the one end of the rope, then the ball move in a circular path with constant speed, but the direction of motion as well as acceleration of the ball in a circular path changes, and the force that pulls the ball towards the center, means the point where I am holding this rope of the thread of the ball, there that force is called centripetal force, and this centripetal force is necessary for a body to be in a circular path, same as the planets and the satellites. Planets go around the sun, and satellites go around the planets, and because of their attraction, pull of attraction between them, that is called gravitational force. That gravitational force between planets and sun gives us necessary centripetal force for the planet to revolve around the sun, same as electrostatic force between electrons and nucleus of an atom provides necessary centripetal force for the electrons to go around the nucleus of an atom. So this force is called gravitational force. So in this universe, in this world universe, you can say every particle, whatever their size, whatever their mass, every particles pull each other, and that pull is called gravitation, and that force is called gravitational force. And this gravitational force is attractive in nature and acts between two bodies in opposite direction. Gravitational force is attractive in nature and it exists between two bodies. So for the gravitational force to exist, there must be two bodies in this universe, whatever their mass or size, it doesn't matter. So gravitational force is an attractive force that exists between two bodies in opposite direction but in equal magnitude. Gravitational force exists between any two bodies. That body may be microscopic or macroscopic, highly massive in this universe. So it is called as universal law. It is called universal law because it holds true for every particles, even microscopic and massive particles, massive bodies. Now let me write this law. So in 1687, in it is clear, yeah, in 1687 AD, Newton formulated a law called gravitation, or Newton's universal law of gravitation. This law is called as universal law, as universal law, because this law holds holds true for all the bodies, and that bodies may be microscopic, whether microscopic or macroscopic, means you can say massive bodies. So that's why Newton's law of gravitation is called as universal law of gravitation. According to this law, means this law states that every body in the universe attracts each other or pulls each other towards their centers, each other with a force is called gravitation. Which is directly proportional to which is directly proportional to the product of masses of the bodies and inversely proportional to the square of the distance between their centers. Means यसले के भन्छ भन्दाखेरि यो युनिभर्समा प्रत्येक बडी, प्रत्येक पार्टिकल, एभ्री पार्टिकल अट्र्याक्ट्स इच अदर, सबै वस्तुले एकअर्कालाई तानेको हुन्छ। अनि त्यो फोर्सलाई हामी के भन्छौँ त ग्राभिटेसन। अनि त्यो ग्राभिटेसनल फोर्स दुईटा बडीको माससँग, दुईटा बडीको पिण्डको मासको प्रोडक्टसँग डाइरेक्टली रिलेसन राख्दछ भने तिनीहरूको सेन्टरबाट, तिनीहरू बिचको सेन्टरदेखिको डिस्टेन्सको स्क्वायरसँग इन्भर्सली रिलेसन राख्दछ। लेट प्रुभ दिस। Consider two bodies of mass m1 and m2 which are at distance d from their centers, let F be the force of gravitation between them, which is first of all directly proportional to, which is directly proportional to the product of their masses, that is F is directly proportional to m1 and m2. Equation 1, keeping at constant d, keeping the distance between them constant. And secondly is inversely proportional to the square of their distance from center, that is F is inversely proportional to d square. Equation 2, keeping m1 and m2 constant, means at constant m1 and m2. Now combining these two equations, combining this, or you can say equation 1 and 2, we get F is proportional to m1 m2 by d square, or F is equal to g m1 m2 by d square. Equation 3rd, where g is where capital G is called as, G is the gravitational constant, universal gravitational constant. G the proportionality which is called as universal gravitational constant. Universal gravitational constant. And this equation 3rd gives what? It gives the force of attraction, gravitational force between two bodies having mass m1 and m2 at distance d from their centers. So this equation, thus the equation 3rd gives the magnitude of gravitational force between two bodies.